Imagine the humid, pitch-black skies over the Australian Northern Territory. It is 3 a.m. Deep in the outback, RAAF Base Tindal is operating at maximum capacity. The flight line is crowded with Royal Australian Air Force F-35A Lightning II stealth fighters and visiting United States Air Force B-52 strategic bombers. It is the most critical, heavily armed staging ground for the defense of the Indo-Pacific. Suddenly, the early warning radars of the Air 6500 Battle Management System detect a massive, low-altitude anomaly pushing in from the Timor Sea. It is not a squadron of Chinese J-20 stealth fighters. It is not a barrage of DF-26 intermediate-range ballistic missiles. It is a swarm. 50 autonomous, propeller-driven loitering munitions, functionally identical to the Iranian-designed Shahed-136 drones that terrorized Ukraine, are skimming just meters above the jungle canopy. They are flying in a decentralized, networked formation. They are utilizing nap-of-the-earth flight profiles to hide from long-range radar, and they are converging directly on the flight line at Tindal. Inside the Air Defense Command bunker, the Australian Tactical Control Officer faces a mathematically impossible decision. He has a battery of enhanced NASAMS, National Advanced Surface-to-Air Missile System, protecting the base. The launchers are loaded with incredibly advanced, highly lethal AMRAAM interceptor missiles. The drones incoming cost approximately $20,000 each. The AMRAAM interceptor missile required to shoot one down costs over $1.2 million. If the commander orders the battery to engage, he will spend $60 million of Australian taxpayer money to destroy $1 million worth of fiberglass and moped engines. But the financial cost is not the true nightmare. The true nightmare is the magazine depth. If the commander fires 50 interceptor missiles to destroy the drone swarm, his launchers are now completely, terrifyingly empty. The reload vehicles are miles away and the process takes precious time. 2 minutes later, the adversary launches their real attack, a volley of hypersonic land attack cruise missiles. The base's radar sees them coming, but the launch tubes are empty. The base, the stealth fighters, and the strategic bombers are annihilated. The adversary didn't use the drones to destroy the base. They used the drones to exhaust the shield. This was the terrifying, undeniable vulnerability of Western air defense at the beginning of the 2020s. We were fighting a war of attrition where the enemy brought a swarm of locusts, and we were trying to shoot them down with a sniper rifle. But in early 2026, the Australian Defence Force violently flipped the script. When that swarm of 50 drones crests the tree line and begins its final dive toward the tarmac at RAAF Tindal, no interceptor missiles are fired. The anti-aircraft artillery remains completely silent. Instead, a massive, unassuming dish antenna mounted on a heavy tactical truck simply rotates toward the swarm. There is no explosion. There is no blinding flash of light. There is no sound. But in a fraction of a millisecond, all 50 drones simply die. Their engines shut off simultaneously. Their navigation lights go dark. They drop from the sky like stones, crashing harmlessly into the red dirt of the outback, completely intact but utterly, permanently paralyzed. The swarm was not shot down. It was fried. Welcome to the era of the high-power microwave. Welcome to the infinite magazine. Welcome to Doctrine of War. Today we are executing a forensic, deep-dive technical analysis into the weapon system that has permanently ended the era of the cheap drone swarm. Here is the thesis for this episode. In modern high-intensity conflict, if your defense costs 100 times more than the enemy's offense, you have already lost the war. You cannot defeat the industrial mass of an authoritarian superpower by firing multi-million-dollar interceptors at plastic drones. To survive, you must deploy a weapon that completely detaches lethality from the physical constraints of ammunition. You must deploy directed energy. If you are beginning to understand why the true balance of geopolitical power is no longer decided solely by who has the fastest missile, but by who controls the electromagnetic spectrum and the brutal mathematics of attrition, hit that like button and subscribe to Doctrine of War. We strip away the science fiction tropes to bring you the cold, kinetic, and highly technical realities of how the free world actually fights, hacks its own hardware, and protects its sanctuaries. Your support ensures we can keep delivering this level of uncompromising strategic analysis. For the last 3 years, military planners watched the drone wars of Eastern Europe and the Middle East with absolute horror. They realized that the cost-exchange ratio was bleeding the West to death. In response, under the aggressive mandates of the 2026 National Defense Strategy and the accelerated procurement of Project Land 156, the Australian military has stopped buying targets and started building invisible shotguns. We are going to break down this saturation nightmare, the exact financial and logistical trap that adversaries use to drain our missile batteries. We are going to explore the cone of death, the hard physics of why high-power microwaves (HPM) are vastly superior to high-energy lasers for defeating swarms. We will analyze the infinite magazine, how hooking a weapon up to a diesel generator completely breaks the enemy's war of attrition. And finally, we will look at the sovereign shield, how these weapons are being integrated into the northern moat to create an impenetrable, layered fortress across the Australian continent. Let us begin by looking at the terrifying mathematics that nearly broke the Western military-industrial complex, and the strategy of the drone swarm. The mathematics of financial suicide. To truly appreciate the absolute, civilization-saving genius of the high-power microwave weapon, you must first understand the catastrophic mathematical failure of traditional air defense. Since the end of the Cold War, the United States, Europe, and Australia designed their air and missile defense networks to counter a very specific type of threat: highly advanced, incredibly fast, and very expensive manned fighter jets and ballistic missiles. We built systems like the Patriot, the Aegis Combat System, and the Standard Missile Family, SM-2, SM-3, SM-6. These interceptors are masterpieces of human engineering. They possess active radar seekers, highly maneuverable thrust-vectoring rocket motors, and the ability to hit a bullet with a bullet in the stratosphere. But all of that exquisite engineering comes with a staggering price tag. A single Patriot PAC-3 MSE interceptor costs roughly $4 million. A single SM-6 missile costs upwards of $4 to $5 million. For 30 years, this price tag was acceptable because the targets we were shooting at, a Russian Su-35 flanker or a Chinese H-6 bomber, cost $50 to $100 million. The cost-exchange ratio was firmly in our favor. You spend $4 million to destroy $50 million. That is good business. But then, the nature of warfare fundamentally, violently shifted. The advent of cheap, commercial off-the-shelf COTS, drone technology, paired with basic GPS modules and explosive payloads, birthed the loitering munition. Weapons like the Iranian Shahed-136, or the thousands of first-person view, FPV, drones flooding the modern battlespace, completely inverted the mathematics of deterrence. These drones are not marvels of engineering. They are built using cheap, fiberglass bodies, powered by engines that you would literally find on a civilian moped or a lawnmower, and guided by commercial microchips that you could buy online for a few dollars. The total unit cost of a Shahed-style drone is estimated to be between $20,000 and $50,000. When an adversary launches a swarm of these drones at a Western military base or a naval destroyer, they are executing an act of deliberate economic warfare. When the U.S. Navy was forced to defend commercial shipping in the Red Sea from Houthi drone swarms in 2023 and 2024, they were regularly ripple-firing $2 million SM-2 missiles to shoot down $20,000 drones. If you extrapolate that mathematical reality to a high-intensity, peer-to-peer conflict with the People's Liberation Army in the Indo-Pacific, the West loses the war in a matter of weeks. The Chinese industrial base can print cheap drones faster than the combined treasuries of the Anglosphere can print money to buy interceptor missiles. It is a path to rapid, undeniable financial insolvency. The magazine depth trap. But as terrifying as the financial cost is, it is only the secondary problem. The primary, fatal vulnerability of traditional air defense is magazine depth. A multi-billion-dollar guided missile destroyer, or a highly advanced ground-based Patriot battery, is constrained by the laws of physics and physical space. A Patriot launcher only carries a set number of missiles, typically 4 PAC-2s or 16 PAC-3s per launcher. An Australian Hobart-class destroyer has exactly 48 vertical launch system (VLS) cells. Once those missiles are fired, the launcher is empty. The magazine is dry. Reloading a Patriot battery requires massive, slow-moving crane trucks, highly trained personnel, and precious time during which the base is completely naked and defenseless. Reloading a naval destroyer's VLS cells at sea is practically impossible. The ship must withdraw from the combat zone, travel hundreds of miles to a secure deep-water port, and use specialized dockside cranes. Authoritarian strategic planners know this. Their doctrine relies heavily on the magazine depletion strategy. If China wants to destroy RAAF Base Tindal or sink an Australian destroyer, they will not lead with their most expensive, highly capable hypersonic cruise missiles. They will lead with the garbage. They will send a massive, coordinated wave of 100 cheap, expendable drones. They know that Western military doctrine dictates that a commander cannot afford to let an unknown contact penetrate their defensive perimeter. The Western commander must shoot. The automated Aegis combat systems will classify the incoming swarm as hostile and begin ripple firing the multi-million-dollar interceptors. The sky will fill with fire. The drones will be obliterated. The Australian or American commander might feel a fleeting sense of victory. But then the radar operators look at their screens. The launchers are empty. And over the horizon the second wave appears. But this time it is not cheap drones. It is a salvo of Mach 4 sea-skimming heavy warhead anti-ship missiles, or DF-26 ballistic missiles plunging from space. Because the defenders expended all of their high-end interceptors swatting gnats, they have absolutely no defense left to stop the sledgehammer. This is the saturation nightmare. The West realized that against a swarm, a missile is the wrong tool for the job. They needed a weapon that did not rely on physical ammunition. They needed to command the electromagnetic spectrum. The laser fallacy, sniper versus shotgun. When the public hears the term directed energy weapons, they almost universally picture lasers. High-energy lasers, HL, have dominated the defense media for years. The US Navy has tested the LAWS, laser weapon system, on their amphibious transport docks, and the British have heavily publicized the Dragonfire laser system. Lasers are incredible pieces of technology. They offer a cost per shot measured in pennies, and the beam travels at the speed of light. But for the specific task of defeating a massive, highly synchronized drone swarm, a laser has severe, fatal limitations. A high-energy laser is fundamentally an optical sniper rifle. It projects an incredibly intense, incredibly narrow beam of focused light. To destroy a drone, the laser must acquire the target, lock its optical tracking gimbals onto a specific vulnerability, like the drone's fuel tank, the battery pack, or the motor, and hold that beam perfectly steady on that exact spot for several seconds. This is called dwell time. The laser has to physically transfer enough thermal energy to burn through the casing and melt the internals. If you are attacked by a single drone, a laser is fantastic. High-power microwave systems completely, permanently sever this logistical tether. An HPM system does not fire physical projectiles. It fires electrons. It fires energy. Therefore, the magazine of an HPM system is not determined by the number of metal tubes bolted to the back of a truck. The magazine is determined entirely by the amount of electricity you can pump into the system. An advanced HPM system like the Epirus Leonidas, which is being heavily integrated into US and Allied architectures, or sovereign Australian prototypes being developed under Project Land 156, is typically powered by a high-output, heavy-duty diesel generator, or it can be plugged directly into the hardened electrical grid of a military base. As long as that diesel generator has fuel, the HPM system has an infinite magazine. The penny per shot paradigm. Let us recalculate the brutal mathematics of the cost-exchange ratio that we discussed earlier. The adversary launches a swarm of 50 Shahid-style loitering munitions at RAAF Base Tindal. Total cost to the adversary, $1 million. Under the old paradigm, the Australian commander fired 50 NASAMS AMRAAM interceptors. Total cost to the Australian taxpayer, $60 million plus empty launchers. Under the new HPM paradigm, the Australian commander orders the microwave array to engage. The diesel generator spins up, drawing a few liters of standard military-grade diesel fuel from its tank to generate the massive electrical pulse. The antenna emits the cone of energy. The swarm is instantly destroyed. What is the cost of that interception? It is not $60 million. It is not even $1,000. The cost of generating that electromagnetic pulse is literally the cost of the diesel fuel burned by the generator during that fraction of a second. The cost per shot drops to a few dollars or even a few pennies. The Australian commander has just destroyed a $1 million enemy strike package using $5 worth of diesel fuel. And crucially, 5 seconds later, the HPM system is fully recharged, fully operational, and ready to engage the next swarm. The magazine is still completely full. This flips the economics of attrition warfare violently back in favor of the defending force. The adversary thought they could bankrupt the West by forcing us to shoot down cheap plastic with expensive titanium. The HPM system turns their cheap plastic into a liability. Furthermore, the logistical footprint is reduced to almost zero. The base commander does not need to worry about the factory in Alabama. He does not need to wait for a C-17 cargo plane to deliver more missiles. To keep his air defense network fully operational for months of continuous combat, he simply needs a standard Australian Army fuel truck to drive over and top off the diesel tank on the generator once a week. We have completely detached lethality from the supply chain. We have weaponized electricity. Part 4. The the Sovereign Shield, Project Land 156 and the Northern Moat. The architecture of Project Land 156. To understand how this futuristic technology is actually being bolted onto the Australian continent in reality, we must look at the specific procurement mandates driving the Australian Defence Force today. In the wake of the Defence Strategic Review and the 2026 National Defence Strategy, the Australian government recognized that the threat of cheap, attritable drone swarms was the single greatest immediate danger to its forward operating bases. This realization accelerated the prioritization of Project Land 156. Project Land 156 is the Australian Army's dedicated program for the acquisition and integration of counter-unmanned aerial systems, CUAS. While the initial phases of the program looked at kinetic interceptors and basic jamming guns, the sheer scale of the swarm threat quickly forced a pivot toward high-end directed energy solutions. The Australian military is not operating in a vacuum. Through the AUKUS Pillar 2 agreements, which focus specifically on advanced capabilities including electronic warfare and directed energy, Australia is heavily leveraging the billions of dollars of research already conducted by the U.S. Department of Defense. Systems that have been tested and validated by the U.S. Army's Rapid Capabilities and Critical Technologies Office, RCCTO, are rapidly migrating to the Australian order of battle. But the ADF is not just buying off-the-shelf American hardware. They are aggressively integrating these HPM systems into the sovereign Australian nervous system, Project AIR 6500. An HPM weapon is useless if it doesn't know where to point. Under AIR 6500, the Australian Joint Air Battle Management System, the HPM arrays are securely networked to the most advanced sensor grid on the planet. If a Royal Australian Air Force E-7A Wedgetail flying hundreds of miles off the coast detects a drone swarm launching from an enemy mothership, that tracking data is fed instantly into the AIR 6500 cloud. The system autonomously processes the threat, calculates the trajectory, and seamlessly hands the targeting coordinates down to the HPM battery sitting on the ground in the Northern Territory. The microwave dish automatically slews to the correct azimuth and elevation, waiting for the swarm to enter its engagement envelope. It is a perfectly automated, flawless kill chain that relies on Australian-built radars, Australian software integration, and directed energy lethality. Protecting the Northern Fortress. Where will these invisible shotguns be deployed? They will be the ultimate perimeter defense for the Northern Moat. As we have discussed extensively on this channel, Australia is currently executing a massive, multi-billion-dollar infrastructure boom across the top half of the continent. The strategy is to turn the North into an impenetrable launching pad for Allied power projection. We are heavily expanding RAAF Base Tindal, building massive bunkers to house US B-52 bombers and our own F-35 stealth fighters. We are revitalizing the remote, bare bases, like RAAF Base Curtin in Western Australia, Learmonth, and Shergar in Queensland to execute the Agile Combat Employment, Doctrine, constantly shifting our fighter jets around a massive geographical shell game to prevent them from being targeted. But as long as these bases are vulnerable to a swarm of $20,000 drones, the billions spent on stealth fighters are at risk. The integration of HPM systems under Project Land 156 provides the ultimate goal-line defense for these critical strategic nodes. This allows for the implementation of a highly efficient layered defense doctrine. When you surround RAAF Tindal with high-power microwave arrays, you completely eliminate the low-end threat. The HPM handles the cheap, massive swarms of loitering munitions, the surveillance quadcopters, and the FPV drones. Because the HPM is handling the cheap garbage, the commander does not have to waste his kinetic missiles. This frees up the highly advanced, incredibly expensive enhanced NASAMS batteries and Patriot systems to focus exclusively on the threats they were actually designed to kill: the high-altitude Chinese H-6 bombers, the supersonic cruise missiles, and the incoming ballistic reentry vehicles. You use electricity to kill the cheap mass, and you save the multi-million-dollar interceptors for the existential threats. This layered architecture makes the Australian Northern Fortress mathematically impossible to overwhelm using cheap, asymmetric tactics. The adversary can send 1,000 drones, and the Australian base simply burns a few extra liters of diesel fuel, wiping the sky clean, while the F-35s launch unimpeded to deliver the real counterstrike. The era of the cheap drone swarm as an unstoppable, asymmetric superweapon is rapidly drawing to a close. For a brief, terrifying window in the early 2020s, authoritarian regimes and proxy militias believed they had found a fatal flaw in the Western way of war. They believed that by mass-producing cheap, explosive-laden RC airplanes, they could bleed the wealthiest, most technologically advanced militaries in history into absolute financial and logistical insolvency. They banked on the assumption that the West was too rigid, too bureaucratic, and too deeply invested in the defense contractor monopoly of expensive kinetic missiles to adapt. The deployment of high-power microwave weapons by the Australian Defence Force and its allies proves that this assumption was a catastrophic miscalculation. The Anglosphere has proven that when forced into an industrial corner, it can still innovate at the speed of survival. By pivoting aggressively to directed energy, we have completely detached the concept of lethality from the physical constraints of an ammunition supply chain. We have taken the enemy's strategy of attrition and inverted it. We have built an invisible shotgun that projects an inescapable cone of death, capable of bricking the microchips of an entire swarm in a fraction of a millisecond. And most importantly, we have achieved the holy grail of air defense logistics: the infinite magazine. As the geopolitical temperature in the Indo-Pacific continues to boil, the adversaries of the free world looking toward the Australian northern moat will no longer just be calculating how many interceptor missiles the ADF has left in their silos. They will have to face the terrifying realization that as long as the diesel generators are running, the Australian skies are guarded by an invisible, impenetrable wall of electromagnetic energy. The swarm has been neutralized, the shield holds firm, and the free world is ready to fight. Thanks for watching Doctrine of War. Do you believe that high-power microwaves are truly the silver bullet to defeat drone swarms, or will adversaries simply develop radiation-hardened, shielded drones to push through the cone of death? Let us know your tactical assessment in the comments below. Stay sharp, stay resilient, and we'll see you in the next one.